Hello class, welcome to Pre-Algebra Lesson 3.5, which is all about interpreting the graphs of proportional relationships. So by the end of this lesson, you should be able to use a graph in order to determine whether two quantities are proportional, and you should be able to interpret meaning from that graph. So we are going to start with this very first example here. We have Tanya exercised for 30 minutes. She noted the calories burned at 3 times during her workout. How can Tanya use this information to find how many calories she burned after 15 minutes of exercise? So if we look at this, you can see Tanya, picture right here. After 10 minutes, she had burned 95 calories. After 20 minutes, she had burned 190 calories. And after 30 minutes of exercise, she had burned 285 calories. So we are going to take this information and we are going to put it on a graph. And actually, if you even look at kind of like these blue lines that represent the exercise, you can see that, they kind of form a little bit of a slant, right? Well, we're going to put them in order. So yesterday, we talked about how when you have a variable that's related to time, it's always going to be your x value. Okay, so here you can see we have time on the x-axis, and it's listed time in minutes, and we have 0, 5, 10, 15, 20, 25, 30. Okay, then on the y-axis, that's the one that goes up and down, is calories. So you can see it goes by 50s. We have 0, 50, 100, 150, 200, 250, 300. And by the way, when you change those numbers, so they're not going by like 1, 2, 3, 4, 5, 6, 7. Okay, when they're not going by ones, that process is called changing the scale. Okay, so the scale of this graph would be that we're going by fives in the x on the x-axis, and that we're going by 50s on the y-axis. Okay, or axis, I should say. Axes is the plural version of the word axis. Okay, so we have our x going off to the right, our y going up, and you can see we have 0 is this bottom corner where those two axes meet. Okay, and that has a very special name. Some of you are maybe familiar with it. It's called the origin. Okay, it's the starting point, and that's a really important thing for you to know when it comes to graphing. One way that students sometimes remember origin as like the starting point is they think of like sometimes they'll think of like Marvel movies and learning the origin stories of the superheroes and that, or any other superheroes too. Like if you go into the world of DC comics too, you can get an origin story of how did that superhero come to be. Okay, their creation, their start. So the word origin means kind of like that start. Okay, and the numbers we use for it are 0, 0. It means that we're located at 0 on the y, 0 on the x. All right, enough about that. Now let's look at this graph. You can see the person that made the graph took kind of what their smartwatch had done. There were a couple of lines showing like how many calories had been burned, and they used those to kind of show like, hey, as I keep working out, I see, the calories burned is increasing by the same amount. So they took it and they graphed it. So if we were to interpret this a little bit, I grabbed a nicer graph that's a little bit cleaner and more like the ones that you will see as you do the work. This version of the graph, it's honestly the same thing but without those blue lines, okay, and without those numbers listed right there. But if we were to kind of use this to try to interpret, I could see that if I were to ask like, well, after 10 minutes, you can see it's like just under 100 calories. At the 20 minutes, you can see it is, if I were to go over, you can see it is just under the 200 calories. And this lines up with, what we were seeing over here. So if we were to look at this information, we could use the graph to try to find how many calories has Tanya burned after 15 minutes of exercise, because that wasn't one of the times that she had checked, right? She had only checked after 10, 20, and 30 minutes. So what we could do is use the same stuff that we've been doing so far. So if I were to take my x and my y, okay, and then make my little table and I do y divided by x, let's check it out. I have 10 and 95, I have 20, 190, and I have 30 minutes is 285. Because if I were to look at 15, I can see it's right there. It looks like it's just under 150, but if I wanted an exact answer, I would have to create an equation. Okay, so 95 divided by 10, that's going to be 9.5. And if I were to do that for any of these points, I would get 9.5. Okay, so that tells me that my constant of proportionality, that k value we talked about in yesterday's lesson, is going to be 9.5. So I could write an equation that says y equals 9.5x, and since x represents number of minutes, what I could do is I could say 9.5 times 15, and if I were to plug that into my calculator, I would end up with the number 142.5 calories. So you can see that the graph gets me pretty close. Like I could tell that I was going to be close to 200, but I didn't know exactly. Or sorry, not close to 200. It was just under 150, but I didn't know how close. So graphs, if you don't have an ordered pair, that's ordered pair is another name for those points that were given, like these 3 points where we knew exactly what they equaled. If you don't have an ordered pair, often your graph is going to be an approximation, okay? Meaning that you can't get exact, and you'd have to figure out what the equation is in order to get exact. All right, now looking at this one, I have a problem for you to try to kind of interpret. We have each 1/4 cup serving of cereal contains 3 grams of protein. How can you use the graph to determine whether the quantities are proportional and to find how many grams of protein are in 1 cup of cereal? Okay, so you can see here we have a little graph, and I want you to just, pause the video and take a minute to think about this. How can you use this graph to determine whether things are proportional? And how would you use that information to find how many grams of protein are in 1 cup of cereal? Okay, so if you already know how many grams are in 1 cup of cereal, I don't want just the answer. I want you to be able to tell me how you got it, okay? So go ahead, pause. Good luck. All right, for this problem, hopefully you were able to use those ordered pairs like that 1/4, 3, or the 1/2, 6, in order to determine like the constant of proportionality would be 12, okay? And then you would be able to say, well, the constant of proportionality, that has to do with the number 1 usually has to be on the bottom, right? Like we talked about that a few days ago with solving for like equivalence ratios and our unit rates and everything. So if you were to do y divided by x, you're left with 12. And your equation would be y equals 12x. If you were to plug 1 in for x, y equals 12 times 1. That means that it's going to be 12 grams of protein. Something that I have not mentioned to you yet, and it's something that's going to come up again later in this video, is in order to determine a proportional relationship, it has to, if you were to graph it, it has to be a straight line. Okay, so it has to be a straight line, meaning there cannot be any sort of curve to it. Okay, and it has to go through the origin. Okay, so you can see here that it goes through that origin, right? It touches it. That tells me that this is a good start. There's a possibility that it could be proportional, but then when I look and I see, hey, this is a completely straight line, there aren't any like bends or curves to it, because sometimes students will say, well, what about something like this? Those are all straight lines put together, but that's not going to be proportional. And in order to be proportional, it has to be just one straight, like continuous line. Okay, but we will practice with that a little bit more in a later example. But for now, we're going to practice some more interpretation from graphs. So this graph shows a proportional relationship between the distance and the amount of time Mr. Brown drives. Okay, what does each of these points represent in the situation? 0, 0, 1, 55, and 5, 275. So something to note is when you are reading ordered pairs, you read them alphabetically. So meaning you always do X and then Y. X and then Y. All right. So looking at this problem, my X value is time. So that means if I were to split this up into a table, X is time, distance is Y. So at 0, 0, that's saying that my time is 0, my distance is 0. What do you think that means? Well, if time is 0 for a road trip, that would mean that it hasn't even started, and that's why we've traveled 0 miles. Okay, 0, 0 would just represent the start of the trip. Okay, then that second ordered pair, we have 1 and 55. So what this would mean, so 1, 55, see how there's an ordered pair, a nice point right there? That tells me that in 1 hour, because that's my label, H stands for hour, in 1 hour, Mr. Brown has traveled 55 miles. Okay, so MI represents miles, distance in miles. So in 1 hour, he's gone 55 miles. And then our last one is 5, 275. And if I were to look at that, I would go up from the 5 and the 275. And it would mean that after 5 hours, he has traveled 275 miles. Okay, so that's kind of one of the biggest skills that you're going to be doing on today's assignment, is just reading graphs and typing up what they mean or answering questions about what they mean. Okay, so keep that in mind. I'm actually going to go back here and point out one important thing. Remember, as we've been working through this lesson, or this chapter, I should say, we have really liked when our X value is 1, right? So he has gone 55 miles in 1 hour. We want to keep that information. Oops, I'm not sure where that came from. So we want to keep that same information when it comes to solving this problem, okay? So he's gone 55 miles in 1 hour, okay? So now, suppose the graph of Mr. Brown's road trip is extended. Find the ordered pair with an x-coordinate of 7. What does this point represent in the situation? If the graph were extended, it will pass through the point 7, blank, and this means Mr. Brown drives blank miles in blank hours. Okay, so use this information, maybe write yourself an equation and see what you get. Use 7 for your X value. Good luck. All right, for this problem, hopefully you determined that if you wrote an equation, it would be y equals 55x, and then you plugged 7 in for x. So y equals 55 times 7, which is 385. So that means our ordered pair would be 7 comma 385, and what that means is that Mr. Brown drives 385 miles in 7 hours. Okay. If you have questions about that, please be sure to reach out for some help. I'm happy to help you. And then here we have our very last page. This is, there's no key concept today because it's just kind of about interpreting graphs, but if there were a key concept for being able to identify a proportional relationship from a graph, this page would be it, okay? We have 3 different graphs here, and the goal was to explain why each graph does or does not show a proportional relationship. So looking at that very first one, the blue one on the left, right here, this one represents a proportional relationship, and the reason it is proportional is because the graph is a straight line that passes through the origin. Okay, and here you can see instead of putting a 0 and a 0, they put, it kind of looks like a weird slanted 0. It's a capital O to represent the origin. Okay, then for our second graph here in the middle, you can see that it's a perfectly straight line, so that's great, but it is nowhere near the origin. So since it doesn't go through that origin, this is not considered a proportional relationship. Okay, and then our last graph right here, it touches the origin, but it has a curve. Okay, it's not a straight line, so it would not be considered a proportional relationship. As soon as you have a curve on your line, you're not going to have numbers that are changing by the same amount. Okay, it's going to be changing by something a little bit different each time. Okay, so that's everything for lesson 3.5. If you have questions about this topic or anything else, please be sure to reach out for some help. I'm happy to help you. Have a great day.